Hey there, my fellow mathletes. We're up to question number 24 now on the 7th grade level Gauss competition from the University of Waterloo, specifically the years 2004. So this is our penultimate question, second to last question, and let's have a bit of a go at it. Hopefully you've already tried it, but I'm looking at this one for the first time. Let's see what we've got. In the Gauss 2004 Olympics, there are 6 competitors and 8 events. The top 3 competitors in each event receive a gold, silver, and bronze, receive gold, silver, and bronze medals respectively. There are no ties at the Gauss Olympics, and no competitor can win more than 1 medal in the same event. So somebody can't get gold and silver. Okay, good to know. Sort of how the regular Olympics work, but if you're not up on that sort of thing, if you're not a sports person, I'm glad that they take the time to clarify that. Each competitor scores 5 points for each gold medal, 3 points for each silver medal, and 1 point for each bronze medal. If one of the competitors has a total of 27 points, what is the maximum number of silver medals she could have won? Ooh, okay. So, sort of the naive way to think about this would be she's got 27 points, 3 points for a silver medal. I'm going to say 27 divided by 3, so she got 9 silver medals. But if I take a look at the answers, I see 6, 2, 3, 4, and 5. 9 is nowhere to be found. And if we take a look at some of the information they gave earlier in the question, there's only 8 events. 6 competitors, 8 events. Okay? So how could she win 9 silvers if there are only 8 events that she can be in? Okay? So then we have to say, okay, well, could she have 8 silvers? So if she had 8 silvers, that would give her a total of 8 times 3 points per silver would give her a 24. Okay? But she has a total of 27 points. So how could she get... She needs some other medal. But she's already competed in all 8 events. Not only that, there's no way using 5 points and some 1 points to get more things. So you can sort of see this question is a little harder than you might think at the start. Okay? So, how am I going to approach this one? So, so far we've noted that 8 events is a bit of a limiting factor. She can't even win 8 silvers. So I think it's actually probably a good idea to then say, well, can she get 7 silvers? And if that doesn't work, 6 silvers. Because if we keep going down the list, we'll definitely be able to sort of figure out sort of exactly the best. If we start bouncing around saying, can she get 3 silvers? Can she get 5? Can she get 2? We won't be sort of getting that largest amount of silvers, that maximum number of silver medals in the most efficient way possible. So I'm going to just sort of briefly write down why she can't get 9 silvers. Okay, so... So right now, it sort of just seems to be a logic thing. Can we use the rules of the Gauss Olympics to rule out 9 or 8 or 7? And eventually, I imagine there will be some math getting in there. So she can't get 9 silvers. There are only 8 events. If she gets 8 silvers, she has a total of 24 points. And because somebody can't win 2 medals in the same event, she couldn't have earned more medals. And with those medals, she could have earned points. So she can't reach her 27 total. Okay? So that's sort of the issue here. So what else could have happened? Well, she could have had 7 silvers, right? So if she had 7 silvers, that would be a total of 7 times 3, 21 points. Okay, so she still needs to get 6 points using other non-silver metals. Well, in order to get 27, we have to make up 6 points. But hey, I could do that with a gold, which is 5, plus a bronze. And so she'd have to win 1 gold, 1 bronze, and then 7 silvers, but then that would be a total of 9 events. So that can't be done. There are only 8 events. So, is that the only way she could have done it? 7 silvers would have been 21 points. We have to make up 6 more points using only golds and bronzes, but there'd be far too many required. No, so I have a feeling that it'll be something like she wins a bunch of golds, because you can't just sort of, you could do sort of 6 bronzes, but then she's competing in 13 events. That's certainly not working. So what I'm actually going to say here is, so I have an idea. I think we could probably keep going, and it might be, no, 6 seems not quite right. I imagine 5 silvers would do the trick. Would 5 silvers? I don't even think 5 silvers would do. Okay. We know it has to be at least 6, so we probably could have just started at 6 because the best possible option is 6. So maybe I wasn't being the smartest when I said do 7. But I've had an idea, actually. Let G be the number of golds she gets, S the number of silvers, and B the number of bronzes. Okay. So since she can only win 1 medal per event, at best we'd have something like the number of golds plus the number of silvers plus the number of bronzes is equal to 8. However, at most we can say that it is at most 8, because maybe she didn't win a medal in some event. Maybe she didn't even compete in some event. I don't know. But the number of points she gets is 5 points per gold, plus 3 points per silver, plus 1 point per bronze, and I know that has to be exactly 27. Okay. What can we do here? Is this helpful? I want to think that this is helpful. I suppose I could subtract one equation from the other. So if I subtract the G, S, and the B, which is at most 8, then I will get something that is at least, if we subtracted the full 8 off of here, we'd get 19, but maybe we're only subtracting 7, maybe we're only subtracting 6 or something like that. But then that gets rid of these B's, and we're left with 2S and 4G. Okay. What can we do here? Well, it's got to be an even number. And so since it's an even number, we've got to have 4G plus 2S is at least 20. Right? Because there's no way we could actually get 19 itself using golds and silvers. They're whole numbers. So now I can divide both sides by 2. 2 golds, twice the number of golds plus the number of silvers has got to be at least 10. And I want to sort of maximize the number of silvers. Okay. So what could I do? Well, really, we only have so many options. We could have... No, actually, So this is useful. I like this, but I feel like it's lacking something. I feel like it's not quite there. If I had 6 silvers and 2 golds... So the problem is, if I were able to solve this inequality, it doesn't guarantee that I've solved this equality. So what I'm going to do is I'm actually just going to sort of scrap this work for a moment. And I'm going to go back, and sometimes this happens. Sometimes you think you're onto something, and it just doesn't quite work. I'm just going to go back and say what happens if she has 6 silvers. Just sort of the way we were doing it before, just with logic and not trying to do it with inequalities or anything like that. So that would be 6 times 3, 18 points accounted for. 27 minus 18, 9 points to go. These have to be made up using golds and bronzes. So 9, the only way to do that is something like 1 gold and 4 bronzes, or 9 bronzes. Neither of those are going to work. So 1 gold, 4 bronzes, or the other extreme, which just isn't working. No way she's going to have silvers and a whole bunch of bronzes. She's got to have golds in there. Okay? I would say that's sort of clear. Neither of these work, because then we'll have, so that'd be 6 plus 1 plus 4 metals. And that's 11, or 6 plus 9, and that's 15 metals. So I'm betting that we'll probably get the answer at the point we need 3 golds. So probably when there's something like 15 points to go. But and so that'd be 4 silvers. Because 4 silvers would be 12. 27 minus 12 is 15, and then we'd have 3 golds, and then we'd have 4 plus 3 plus no bronzes is 7, and that's less than the 8 events required. Okay. So definitely feeling good about that. If she has... So by the way, this can't work. If she has 5 silvers. So if she doesn't have this, I know that I can do it with 4 silvers. I've just verbally confirmed that to myself. But we'd have 5 times 3, she'd have 15 points already. And so we'd need 21 minus 15 is 12, and we'd have to make that up. And that could be done with 2 golds and 2 bronzes. 1 gold and 7 bronzes, or 0 golds and 12 bronzes. That would be 9 metals. That wouldn't work. This one here would be 13 metals. That wouldn't work. And finally 17 metals, and that wouldn't work either. Okay? But she can have 4 silvers and 3 golds. So 4 plus 3 is 7 metals, and so she could have gotten them at different events. And 4 times 3 plus 3 times 5 for the golds is 12, plus 15 is 27. So she can have 4 silver. She can't have 5. She can't have 6. She can't have 7. She can't have 8. She can't have 9. We've ruled out all those other ones. The best she could have, the most number of silvers she could have, is 4 silvers. Okay? And we didn't really use a whole... We used some basic arithmetic here, but I was trying to set up equations, and that certainly didn't work for me. Okay? It was just more, what if she had this? What if she did this? It was just case-based... we were breaking it down into cases and just using logic. Now, maybe you had a way to do it with equations, and I'd love to hear that in the comments, because I don't think I can turn my inequality and an equality into giving me the right answer any faster. Okay? So if you did it some other way, I would love to hear about it. But for now, let's figure out which one 4 is. 4 is D. That'd be D. D is our answer. All right, now I'm excited. Hopefully you are as well, because we've got one more question to go, and that's question number 25. So hopefully you guys will join me in the next video for that one. And until then, have a wonderful day.